Okay, picking up where we left off at, I started talking about g here, which is y equals 42.5. Now, whenever you have y by itself, and it's taken to the first power, and there's no x, automatically it's a function, because your x values will not repeat here. Now here, for this problem, we need to get y by itself. So we'll subtract 12x on both sides. So we have 12y is equal to a negative 12x. We'll divide each side by 12. And y is equal to negative x. Now, there will not be any repeaters here, so your answer still would be a function. Okay, now x equals negative 13. This is saying in this problem here, no matter what you put in for y, x is always going to be negative 13. So we know that is not a function. Because this will have repeating x's. Now, it says note, all diagonal and horizontal lines, which is diagonal lines, are typically your y equals mx plus b. That's typically your diagonal line. And then your horizontal lines are y is equal to a number, which we all learned earlier. Okay, so they are functions. Now, all vertical lines, we know that that's x is equal to a number. And they are not functions. Okay, now we go to the next page. It says determine whether the given relation is a function. Now we have y is equal to x squared minus 3. No matter where you draw a vertical line at here, it would only hit once. Hit only one point on this graph. So this is a function. Now we come to b. We have x equals 1/2 y squared minus 4. Now we know if we drew a vertical line here, it will hit more than one point on this graph. So it's not a function. Now we come here to c. We have x minus 1 equals 1/4 y to the third. Now when we look at this graph, it looks as though if you drew a line right here, it would hit more than one point. But actually, if you got even closer to this graph, you would see that these do not have the same x value. They're slightly different, even though they look like they have the same x value. So this is a function. Now, for d, with this y to the fourth equals 20x plus 80, you notice if we draw a vertical line, it will hit at 2 points. So this is not a function. Now, note, if y is ever raised to an even power, now we know our even numbers are 2, 4, 6, 8, 10, 12, and so on, then it is not a function. Automatically is not a function if y is ever raised to an even power. Now we come to example 6. It says Now in this last problem, it says sketch the graph of a function whose domain is -2 is less than or equal to x, which is less than 5, and whose range is -4 is less than y, which is less than or equal to 2. Now I took the liberty of pre-drawing a graph here. Now it wasn't really any specific graph that you needed to draw, it just needed to fit these specifications. For one thing, it's telling you here that x is greater than or equal to -2. So when we look at our domain, we must make sure that x is greater than or equal to -2, which we have here. This is x is -2, and that's as far out as the x-axis go. And then it said x must be less than or equal to 5. We have that here. Now we put a circle here because when you have a closed circle, that means that that number is included in the graph. An open circle means it's not included. And we know if x is less than 5, we do not include 5. So this takes care of our x values. Now if you notice here, I have a solid line here, and I have a broken line here. Solid line means that this value is included. A broken line means that this value is not included. Okay, now we go to the range. The range says that -4 is less than y, and also y is less than or equal to 2. So what we do here, we go to our y values. We have where y is 2. If you notice that this line includes that y is 2. Now, it says y is also greater than -4. We will have an open circle on -4 because -4 is not included. Now, if you look at this graph here, it says, well, it just asks us to sketch the graph. So this is a sketch of the graph. You could have drawn the graph slightly different, but this is a sketch of the domain and range coming together. And this is it for section 1.6.